Okay, so chapter 14, question 7. Let's have a look. So it states with differentiate each of the following. So let's say y is equal to e to the minus x. So dy by dx is going to be e to the minus x, and the minus comes down. There we are. In terms of b, it is e to the 11x, and again dy by dx is equal to e to the 11x, and the 11 comes down, so 11e to the 11x. And then finally we have y equals 6 e to the 5x, and again we have 6 e to the 5x, and the 5 comes down, but it needs to be multiplied, so we end up with 30 e to the 5x. And that's question 7. Straightforward. Question 8. Okay, A. Ooh, quite a few of these. Ln of 2x minus 5 equals 8, and they want it to be solved with an exact solution. Okay, let's raise everything to the power of e to the power of x. So if we have e to the power of ln 2x minus 5 equals e to the 8, that cancels itself out to give you just 2x minus 5 equals e to the 8. 2x is equal to e to the 8 plus 5, giving you a value of x is equal to e to the 8 plus 5 over 2. B. E to the 4x equals 5. Okay, so something like that. We're going to take the ln of e to the 4x, which is equal to the ln of 5, and then I can move the 4x outside. I can say 4x ln e is equal to ln 5. Just double check it, but I'm fairly certain ln e is just 1, so we've now got 4x equals ln 5, meaning x is equal to the ln of 5 over 4. Right then. On with C now. C, 24 minus e to the minus 2x equals 10. Okay, so let's make that positive in terms of 24 minus 10 is 14, which is equal to e to the 2x. If I take the ln of both sides, I get ln 14 equals 2x. Okay, using the same idea as the previous question. So ln 14 divided by 2 is equal to x. D. Ln x plus the ln of x minus 3 equals 0. Okay, so if we raise it all to the power of e to the e, we will be left with x plus x minus 3 equals e to the 0, which is 1. Okay, that was e to the 0, and anything to the 0 is 1. So we end up with 2x 2x minus 3, which we'll bring over there, is equal to 4, because it becomes a plus 3 with the 1. So x is equal to 2. So looking at the answers, that's what you think it would be. Well, that's what I thought it was going to be. And it is wrong. Okay, when you put it e to the x, you can't. What we need to do first is combine these two here. So let's just take that out and have another look at it, okay? And watch out for these mistakes. Also, in checking my answers, I came across the fact that I dropped a minus there, which would have carried on through there. So with this, two lunds adding together, that's the same as things multiplying. So we end up with x squared minus 3x equals 0. And so with that, we can say the x squared minus 3x equals 1, putting it all to the power of e to the, raising it all to the power of e, okay, or e to the power of it, okay. So that becomes the 1 there. So with that in mind, we get x squared minus 3x minus 1 is equal to 0. Putting that through a quadratic solver, okay, on that calculator. Right then, so I don't think this has got a good solution on it. 1 minus 3 and minus 1. And we get x is equal to 3 plus root 13 over 2, which is roughly equal to 3.3. And we also get x equals 3 minus root 13 over 2, which is roughly equal to minus 0.302. Disregard this negative answer because we can't do the ln of a minus number, can we? I don't think you can. Yeah, so the answer is 3 plus root 13 over 2. All right. D done. E next. E to the x plus e to the minus x equals 2. Let's have a think about that one. So what do we have there? We've got e to the x plus 1 over e to the x equals 2. I'm going to multiply by e to the x. I'm going to get e to the 2x, or e to the x squared, plus 1 equals 2 e to the x. And with that, I can say e to the 2x minus 2e to the x plus 1 equals 0. That makes a quadratic because I can take e to the x out as my item because I've got a squared minus 2 plus 1 as my coefficients there. Okay, if you want to see it on what I'm saying is e to the x equals, I don't know, let's go with z. So we've got z squared minus 2z plus 1 equals 0. And when you do the solve on that, Is that -1 and -1? Just check it. Calculator time. Polynomials. Okay, where are we at? 1 minus 2 and 1. And so the answer is x equals 1 or z equals 1 and z equals 1. Okay, so z equals 1, z equals 1. So what we've got is basically e to the x equals 1, which makes x equal to 0. Because raised to the power of 0 is 1. Okay, and finally f. The ln of 2 plus the ln of x equals 4. Those two things are adding together so they can be multiplied. So the ln of 2x is equal to 4. So now raise it all to the power e to the power of it. So we end up with 2x equals e to the power of 4. And so we end up with x is equal to e to the power of 4 over 2. Superb. Right, question 9 for the end of this video. Let's have a look. Question 9. The price of a computer system can be modeled by this formula. P is equal to 100 plus 850 e to the power of a half. Okay. Oh, that's not a power of a half, that's a t. Wow, I need to get my eyes checked on that one. Okay, so t. Where p is the price of the system in pounds and t is the age of the computer in years after being purchased. Calculate the new price of the system. So the new price of the system would be when t is equal to 0. Okay, so we have p is equal to 100 plus 850 e to the minus 0 over 2. E to the 0 is 1. 850 plus 100, 950 pounds. Part B. Calculate the price after 3 years, giving your answer to the nearest pound. Okay, so after 3 years, t is equal to 3 and price will be equal to 100 plus 850 times minus e to the minus 3 over 2. So e to the minus 3 over 2 comes out as 0.223. So we've got to, so this is 0.223. So 0.223 times 850, 189, plus 100 is 289 pounds and 66. They wanted it to the nearest pound, so 290 pounds. C. When will it be worth less than 200? Okay, when will it be worth less than 200? So with that, we need to reverse engineer this and say that the price is 200, and that will equal 100 plus the 850 e to the minus t over 2. So straight away, move the 100, and the 850 divided by 850 is equal to e to the minus t over 2. We will take the ln of both sides. So we've got the ln of, change it to 10 over 85 equals minus t over 2. multiply it all by 2. In fact, minus 2 I think we will be going for on there. Yeah. That should equal 2. So what does that give us? So 10 divided by 85 was 2/17. Just never did the division by 5. The ln of that is minus 2.14. Okay, times by minus 2 gives us 4.28 is equal to t. So what will it be? Calculate when will it be worth less than £200? It's worth less than £200 after 4.28 years. Okay, so when t is greater than 4.3 years to 2 dp. Okay, not 2 dp, 2 significant figures. Okay, that was C. Find its price as, so when D, as t tends to infinity, find its price as t tends to infinity. So P will equal 100 plus e to the 850. E to the minus infinity over 2. So what happens as we raise e to the power to something really big and negative? Okay, so when we have a negative number in there, okay, that's really big, we end up with e getting to about 0. Okay, it becomes 0 because if you think about the graph, it comes like this, and so as you end up with a negative infinity, it's getting closer and closer to 0 every time. So times 0, so basically P is equal to £100. Okay, sketch the graph showing P against T. I just did it there. I better do it a bit better, I suppose. So if we have a axis like this, we can have price on here, we can have T on here. Okay, and as we go up, we have a £100 there. What was it at 950? We had it as when t equals 0, we went through at 950. And then by t3, we were at 290. So we come in here and we have like this. And as we go out to this way, it gets lower and lower and lower. And so that should be the 950 mark when t is equal to 0. And I don't think we need to put anything else on for that. We could put the suggestion that it never gets less than 100. Okay. There you go. and comment on the appropriateness of this model. Well, as a computer system goes, it does seem to lose its price very rapidly. So the second-hand price of the PC drops very rapidly. The £100 price minimum limit seems odd, as in 5 years no one will pay that, but in 100 years people will pay more for the antique computer. Maybe. So maybe it should like dip and go back up, but ultimately it's all right. So yeah, love it. Right, spelling so bad that the computer can't even tell what I am trying to spell. Minimum. All right, that's it for question 9. We will see you on the next video.